10:02 already. Man, those last few seconds right before lecture fly by. So let's just get into this. So the next homework assignment is out. We're back to a homework week. Last week and was a project week. I was just getting you ready for front end 2, which I don't know if you all feel this, but projects weeks feel a bit different than homework weeks. Homework weeks have a very clear goal. Here's a homework assignment. I need you to get to the point where you can do this homework assignment. The project, there wasn't much I had to show you except the Docker Compose file. So I was just kind of showing you stuff. So this week we'll be getting you to the point where you can complete these 4 objectives for this homework assignment. I just want to walk through them a little bit right now. As usual, I won't read the whole thing and go into too much detail. We can during Q&A if you'd like. But with homework 8, we want to enable authentication on our web servers. So for this, we're going to need a few things: salting and hashing, which we'll talk about today, to be able to securely store user passwords; registration, which is mostly what you would think it is. A user can provide a username and password, and then you store that username and password on the server. Normally, we would use a database for this. If you want to just use file IO, I'm going to be okay with that. For example, if you want to store usernames and hashed passwords in a CSV file, I'm okay with that, just so you don't have to mess with a database. If you do want to use a database, I'd recommend using Docker for the homework and then setting up a database like that. That way testing is a lot smoother, or else it's going to be quite a bit of work just for Nick and I to verify your homework. Grading might take a while, and things like that, logistical things like that. With this, there was a big thing I want to mention here. I just got to make sure I know what it is. The password validation. So for this, you choose SQLite would be fine. Yeah. If you're using another language, like Python has really great built-in SQLite support, that'd be fine. As long as your data persists in some way. Your data needs to live through a server restart. However you can get that to work, it's fine with me. I'm not going to be picky about that aspect of this assignment because I want to focus on how to authenticate users. So with this, you have to choose some password criteria. I don't care what your criteria are. You could use the common at least 8 characters, uppercase, lowercase, numeric, and special character. You can stick with that. It's kind of has become pretty standard out there. But whatever criteria you choose, you have to verify those criteria on the server. And if a user chooses an incorrect password, you have to send them a message that says, hey, your password's no good, and this is why. These are the criteria that you don't have. So that's one feature we want to have in this registration process, is some form of password validation to make sure their passwords are at least decently strong or at least not embarrassingly weak. So that, and if the user properly registers, you save that data, which persists through a restart. I said I wouldn't read this whole thing, and I ended up going through the whole thing, but whatever, it's fine. And then the next step, the other side of registration, authentication. So once a user has registered, add a new page to your site that users can only visit if they verify that they have an account attached to them, and that page should display something specific to that user. This can be as simple as hello username. It doesn't have to be anything complicated, but I want to make sure that authentication is working. And this, of course, is where you could have like edit your profile and DM people in your name and things like that. But the functionality of the authentication has to all be there. Timothy, just hang on a second or read Objective 4. That's what Objective 4 is all about. I haven't even gotten through the homework. You don't have to ask that yet. So when somebody goes to this page, they're going to be prompted for their username and password. So you can have a page that shows a form. Yeah, it's fine, Tim. That shows a form that says enter your username and password to authenticate. And then if they enter a proper username and password according to your database, so you'll take their username, look up their hashed password, apply the salt, hash the password they provide, check those. If everything checks out there, then you're going to show them some custom page that says at least their username somewhere in there, something to say that, hey, you are who you say you are, and here's content specific for you. And if they have an invalid username and password, you should redirect them somewhere else, send them some other content that either redirect or send them a different custom HTML that says, hey, you can't be here. Try again. For the fourth objective, this is where we're getting the persistent sessions that Timothy asked about. If somebody visits the page for objective 3 and then visits it again, before objective 4, they should be prompted for their username and password again. Every time they do take any action on your page that requires them to verify their identity, you'll be asking them for their username and password every single time. And that username and password is going to have to come along with the HTTP request. You'll verify their identity using their username and password, and then serve them a response accordingly if they have a valid username and password. This is not very functional. It's not user-friendly. You would not use a site that requires this. So for Objective 4, we want the more user-friendly feature of giving them some secure session token when they authenticate, setting that as a cookie, and then every time they visit a new page, check that cookie to verify that they did at one time verify their identity. Then you can be confident that they did authenticate at some point because you have that cookie set, and then not prompt them for their username and password again, because you know that they authenticated, you know who they authenticated as, and then you can let them navigate your site with basically free reign after that. So that's what we want. Persistent authentication is our goal, objective 4, and then we have 3 objectives to build up to that, to have some sort of login and then navigate the site as that particular user. And that's how we want to get there, is by storing a salted hash of their password, verifying that hash at authentication, and then setting a secure token at authentication as a cookie, and then having them submit that cookie with every request, which cookies do automatically. They'll send that cookie with every single request, that token as a cookie, and then you can verify their identity that way. Do we need no, you don't need a way to log out. So anything I didn't put on here, you don't need. We're building the basic infrastructure. Like, these are the juicy bits, I'd say, of authentication, of how to handle passwords, how to authenticate, and how to handle all that. There are tons of more features that we'd want to add, like logout, that you would add in a typical site. But this is the crux of the technical aspects of what goes into that. For example, a logout button, you would just unset the cookie or set it to a blank value. It's not that complicated. So the homework is focusing on the technically complicated aspects of authentication. And then, yeah, there are lots of user-friendly features that we could add, and that you should probably add to your apps. I mean, I won't be looking specifically for a logout button in your app, but you can add one to your apps to make it a little more user-friendly, to let people blank out those cookies with a logout button. With that, of course, phase 2 coming up. But with that, let's go. Why do I feel so lost right now? Oh, because I want this out of the way. It's behind it. That's what I'm looking for. So with that, let's talk about authentication and how we're going to do this, and most specifically, how we're going to do this securely. So the whole point of authentication is to be secure, is to ensure the privacy of your users. So security and privacy, both, those are commonly interchanged. But security and privacy here, we want in our apps. So let's talk about how to build that, because if we didn't have secure authentication, there is no privacy, because anybody, no security or privacy, because anybody could just say, I am this user, and then you just treat them as that user. We don't want people just claiming that they are a user. We want to do this in a secure fashion. Yeah, for logout, the session should be cleared on the server as well, yeah. Or else, so if you're logging out, A few reasons why you would want to log out. If you're using a shared computer is one of the big ones. If you're using a shared computer, somebody might have something installed that would be able to grab that session ID, that session token, while they're using that machine. I think is what is Coffee and Burger's concern. That if somebody has that token and you don't clear it on the server, as well as the cookie, then they could still authenticate as you. So yeah, I should have mentioned that as well. You'll clear your database, whatever you have in your database associated with that session token, you would clear that out as well. And we'll talk about session tokens on Wednesday. So if you're looking forward to seeing that today, I'm sorry to disappoint, but no session tokens today. But we will have, we will store a hash of the session token. We'll see that on Wednesday. And that hash, that would have to be cleared as well. Because if you're logging out, you're probably concerned about somebody stealing your cookies. Or the more common case of somebody just sitting down at your laptop going to that page. You don't want them authenticated as you. But if you have a shared computer, they could steal your cookies too. You don't want that. So far, just a little more background, a little more setup here. So far, everything we've done in this class assumes that a user is just a generic user, and we treat every single user the same. No exception in phase 2 of the project. We have like one single user that we treat as the user, and no matter where those requests are coming from, no matter who it is on the other side, we're treating every single user the exact same. The only small exception that we had was setting a cookie on the first visit. So whether this is a user using a machine and browser that we've seen before and set that cookie or not, we would treat them slightly different. We had basically two different users, a user visiting for the first time or a user visiting for a subsequent visit. That was the only custom content we've been delivering so far. Is just that. Other than that, everything was exactly the same. We could let users send us information, and we'd send back something custom based on that information. For example, they sent us a query string, and then we'd parse that query string and send it back. But it didn't matter who was sending that query string. We didn't care who was on the other side. We just know when we get this query string, we're sending this information back. Doesn't matter who it was. So we want to start adding features that do care who's on the other end. And we want to have this idea of user accounts and having a user being able to log in and actually remembering that user across multiple visits. This is what we want. This is a feature that you expect in most apps that you use. Anything that you're really interacting with, you have a user account associated with that. The only apps you really use that don't have this are apps that you're just going there to consume content. Like you wouldn't, unless you're editing pages, you wouldn't log into Wikipedia, for example. You're just there to consume content. Once you want to make edits, you would create an account, log in, authenticate, and everything. But to get those interactive features, we would want login. For example, the chat app that we saw last week, that we did get up for those of you who left. We did get it up and running during Q&A, and I'll bring that back this Friday with authentication. But that chat app just treated every user as the same, and I had a little bit of JavaScript that generated a random username for you, and then when you sent a message, that username would be associated with your message. But there was no authentication. You could just go in the JavaScript console. Someone says something you don't like. You go into the JavaScript console, you say username equals that username of the person I don't like, and then you start spamming stupid things in their name. There's no form of authentication in that. No security, no privacy, nothing. I guess there was privacy because nobody knew who you were, but no real security. Everything was just out in the open, just out there. So this is what we want. Any feature where you're really interacting with a page, you want these user accounts. You want the app to remember you. So let's build that functionality. There are two aspects of this, two primary aspects, I should say. Yeah, okay. I thought I got rid of the slide, but I do still need it. So I was right to not. Two main aspects to this that we're all very familiar with, but let's just go over them just to get a little terminology out there and make sure. Registration and authentication. So registration is when you create an account. You're going to, at a minimum, be asked for your username and password. And authentication, where you're again asked for your username and password. And if that username and password match somebody who registered with that username and password pair, we're going to be fairly confident. We're going to be sure enough for our purposes that that is the actual user on the other end. Of course, they might have been hacked. They might have had their password stolen or something. But there's really nothing we can do about that, unfortunately. If they provide the right username and password, we're going to authenticate them. Which is to say, we're verifying that they are who they say they are, and we're going to let them proceed as who they are. Actually, I take that back. We do have a little bit. We do have 2FA these days. We have, man, I'm blanking on it. But when you log into UB, you get a push to your phone and things like that. Duo. We have things like Duo, which adds another layer of protection. So even if that password's compromised, there's something we can do about that. I shouldn't say nothing, but and then yeah, if they provide that right username and password, we're going to log them in and serve content specific to them, which is most likely private content that we don't want just anybody to have access to. So we want to verify someone's identity. Think of somebody seeing your class registration, your bill for UB, for tuition and everything. You don't want people seeing that if they're not you, if they're not somebody, or at least somebody that you gave permission to view that information. So with registration, at a minimum, we're going to provide a username and password at some point. It's not necessarily right away, or it's not necessarily at this time. For example, if you log in with Google, at some point you provided Google a username and password. So you're not using that, you're not providing that username and password for that specific site. But at some point during the registration process, at a minimum, username and password. I'm not aware of any sites that don't use username and password. It is pretty much the standard, unless you're logging into like a smart card site where you put your card into a card reader. If you've been exposed to any of that, there are some other options, but this is pretty much the standard username and password. Ubiquitous these days. Sometimes you'll be asked, actually most times these days, you'll be asked to also provide a valid email address that will be verified. So on the server, this is something that we often want to do is associate the account. Instead of just letting somebody choose a username, we also want to associate that account with a valid verified email address. And you see this out there in the wild. If you provide an email address when you sign up, some signups only ask for an email address. This is Zoom's sign up right here. Some of them only ask you for an email address. Then they'll send you an email with a custom link for you with a token in the URL. And then you click on that link, and then you get to the part where you get to choose a password. And commonly your username can just be your email. I think Zoom just uses our email as the username. But then you'll be prompted for a password. So they'll verify that email is a valid email, and that you are. I'll be a little careful here. You want to verify that the user is the one who owns that email address. Not necessarily true, but we do know that whoever registers does have access to that email address. So no matter who filled out this form, because I could go to one of these forms and fill out your email address. There's nothing stopping me from doing that. But whoever clicked on that link may be like, hey, I didn't go to Zoom, but hey, that sounds like a good idea. So we can't verify whoever filled out this form. But you got to think like that in the security world. When it comes to privacy, you have to know that can happen. So whatever they put in here, you can't verify. If this was enter your name and email address, we can't associate that name with the account. That's not verified in any way. But the user email address, we can. They had access to that because they visited that link with that secure token that somebody would not be able to guess. So we can verify that account is associated with that email address. So, why do we want to verify email? I got a quick demo for you. It shouldn't take too long. I think I can get this one set up quick. Okay. So I'm logged into Fury. If you've taken my, actually most of you may have taken my 116. I'm thinking I don't consider the Java 116 the 116 anymore, apparently, in my mind. Anyway, that's not what we're here to talk about. I'm logged into Fury, and I had this Q&A site literally called Question and Answer, which is just an open source project. It's open source software that I installed on my server and was running for students to be able to ask questions, and me and the TAs could go in there and answer questions. It was kind of a clone of Stack Overflow, and I was trying to get that feel of it, of a Stack Overflow Q&A style question and answer site. It had issues, user experience issues, so I don't use it anymore. But it was something I used for a couple of years. It's possible that some of you took 116 when I was using this, or 115. I was using this in 115. Right, that's what I'm completely confusing myself. I never taught the Java 116. This was all 115. But some of you might have taken 115 with this Q&A site. Anyway, this uses a MySQL database. So I'm going to just go into my command history here. I'm going to go into the MySQL command line and take a look at some of the data that's in here. And this may seem like a tangent, but that does sound familiar. Yeah, we've been talking. I think you took my 115, 116, and now the 312, if I remember correctly. But I have to hold on. I have to focus a second. What's my password for this? I just did this before lecture, but I already forgot the password. Let's resize this thing a little bit so my face isn't in the way. And so I'm in the... Oh, come on. So I'm in the MySQL command line, and I want to check out some of the things in here. The tables that this app sets up quite a few tables to store all the information that's in there. And the one that I want to focus on today is the users. So if I look at the columns for the user, right? For some reason I completely blanked for a bit and thought that I taught the Java version of 116 before. I never taught that. I came in. Hertz taught all of the Java 116, and then I came in and took over 116 when we switched to Scala. And I know most of you haven't taken the Scala 116 yet. I didn't see, I think 2 of you in my 116 was that was our co-teaching semester. When a lot of you took it, was in the era of, yeah, Roman, you took it in the barnyard era. We're in a whole new era now. It's I kind of miss the barnyard, honestly, but so we have these tables. This users table, which is going to store all of our user account information, has some quite a few fields for us. I only am concerned, and I pre-did these because I always fumble around in live examples. I just want to show a few of these fields. The user ID, which has the auto increment attribute set. So this is every time somebody creates an account, they're going to get the next number that's available. A created, which is the date that they were created this account. The email address associated with this account, and the handle, whatever username they chose. So let's do this and see all of my users for this 115 Q&A site. And apparently I have 105,000 students in this class who are eager to ask questions and get answers. And this is what we want to talk about in terms of authentication. And I believe this council does not save the whole history, so we can only go up a little bit. But as you can tell, looking at all these, this is just random crap for most of these. It's just random garbage email addresses, random garbage usernames. Some of them are kind of making sense, but they're clearly randomly generated. Randomly generated usernames, randomly generated email addresses. This is what happens when you don't verify email addresses. So I actually had a big problem with this site of having these obviously bots just spamming user accounts, creating 100,000 user accounts. Well, let's say 105,000. We'll say I had 223 actual legitimate students. Probably more than that, but not by much. But mostly just bot accounts in here. So I had to do something about this. I did require them. There's a feature in this app where you can require them to verify their email address. Luckily, I had that set. So they weren't able to actually post information, but they were able to create the accounts. Actually, now that I mention it, I know where they had some information. Email code. It's probably in a different table. But so they weren't able to actually make posts. So I didn't actually notice this for a while, but it was a problem. And you can see the frequency of this. Every few minutes, they're creating another one of these accounts. So this is what happens when you don't have email verification. I did have email verification, but I did add a CAPTCHA. That's what finally stopped them. So unfortunately, I had to subject my legitimate students to CAPTCHA, but it is what it is. Because what these were doing, most of them were doing when I looked into what they were actually accessing and what they were actually doing, was linking other accounts. And it was actually in a different class we were talking about this, and a student pointed out why they're doing this. They actually worked for one of these companies, hopefully one that's not so shady, but they would link to one of their pages, and nobody could actually, it didn't affect my actual users at all, but they would just link in their profile page. And somebody pointed out that these are all SEO companies. To be able to get a link from a .edu site. Buffalo.edu is a trusted site. It weighs pretty heavily in Google's and other search engines' algorithms. So if they have a link to their crappy site from UB, it actually raises their SEO ranking by quite a bit. So that's what they were trying to do. They were trying to get anything on a .edu server linking to their site. And they did that through these bots, just looking for any place where they can just spam random crap. And then companies would presumably pay them money to increase their SEO, and this is one of the things that they do, is just spam random crap to servers that they are not welcome on. So this is one thing that can happen. Big reason why we verify email, because if I didn't verify the email, they'd be asking questions on this Q&A site and being like, hey, check out my site, you can buy Insta followers and shit like that. We don't want any of that. So it's easy to say, and I've said it before, I learned my lesson. This is why I like to show this one, because I learned my lesson through this, is it's easy to say, well, yeah, I mean, technically somebody not associated with an email address could register for your account, but who cares if they don't have a valid email address? But this is why. The bots are out there. These aren't people, human beings at their computers trying, creating accounts and stuff. These are people who write bots that just spam the whole internet, scanning for vulnerabilities, and they actually do exist. They are hitting our servers. I looked at the logs. Unfortunately, my command line here truncates the output, but I checked the very beginning. It took like 3 days before my first bot hit, and then they just slowly increased in frequency over time until I had one every few minutes. I finally shut down the server, so they can't get anything else up there. But those bots are out there. They are actually a real threat. So verifying the email is one way to get them to at least not be able to post. They can still create the accounts, but they can never verify that email. And in fact, in Zoom's case, if you start with the email, they still have to create some entry in a database to say this token that we sent is associated to this email. But that's all the damage that those bots can do, is storing up that one line in a table in a database somewhere. Can they get into trouble doing that? I don't actually think so. Possibly if I had a policy, a stated policy, end user agreement and things like that on my site, I could probably give them a cease and desist. But as far as I guess it depends on what you mean by trouble. But I could, if I could show. You'd have to be able to show damages is the problem. So if they actually cause enough traffic to trigger, effectively have a DOS attack and shut down your server, and you could prove how much that costs you, you could go after them and sue them for those damages. But yeah, exactly, Tom. And as Tom is pointing out, you have to find them first, and that's going to be the tricky part. I looked up some of the IP addresses associated with those accounts, and they're from all over the world, and almost certainly VPNs. So finding them is going to be the first trick, and then proving damages. Most likely, they're not bringing down servers; they're not at that level of spam. So it'd be really hard to get them in trouble. It's mostly adding in things to prevent that from happening. Having the email verification, adding CAPTCHAs, and just preventing the bots. And you see the effects of that all over the internet. Most things you visit are going to have some form of CAPTCHA and email verification, because those bots are out there, and there's really no effective way to get them in trouble or stop them from doing what they're doing. There's some people just don't want to make an honest living, and unfortunately, it's just something we got to live with. We just gotta go on the offensive or defensive and fight them directly. There's no one that we can tell on them to and say, tell them to stop. Just doesn't exist, unfortunately. So we need to authenticate. Once somebody provides, I got way more sidetracked than I expected to on that one. But it's interesting stuff, I believe, anyway. So on the server, somebody submits this username and password. We store that username and password. And then whenever they provide that username and password again, we say you are who you say you are, and we can treat them as that person from then on. There's one huge problem with this, and it's pretty much everything else that we'll talk about for these slides, at least, which we might not get through today. At least not all the examples. I want to go into the code again and show some stuff. But there's one huge problem with this. We are storing username and password on our server. We have to do that. That's how this whole thing works. Because if we don't store these two pieces of information, when somebody goes to authenticate to log in, what do we do if we didn't store this information? So this data is stored on our server, probably in a database somewhere. So what if the database is compromised is our big question. As much as, we're going to prepare our statements. We're going to secure our access to need to know to our database and protect our passwords for the database and everything. We're going to lock that down as much as we can, but an attack still can be successful. Even if there's no attack and nobody hacks into this server, there are people who have access to the database that just need access to the database in order to keep the site running. So any of your DevOps people, any of your admins, any of you, like your sysadmin, he's going to have, or she is going to have access. There are people who just have to have access to this information. So if they have access, they can use any account. Most likely, at least some developers have access to this as well. Anybody working on these features, they might at some point need or accidentally have access to the production passwords. Like, it can happen. If they have to do testing on production, it's going to the DB admin and being like, hey, you know, can I just have that password? I got a quick test that I have to make. Well, now they have access to everything. A lot of things can happen. A lot of people can have legitimate access to this database. So we don't want, what we're going to build here, what we're going to see is protecting this information such a way that even the sysadmin would not be able to access your account. At least not through the username and password. They will not be able to access your password. There are other ways they could probably just, set their values to logged in as you, but we don't want them being able to recover your password. So much less an attacker with a successful injection attack. We don't even want the sysadmin to know your password. That's what we want. And of course, step one of this, you've probably heard this plenty of times. We never, ever, ever store password in plain text. We never store is a key word that we will actually talk about. We'll never store a password in plain text. And this is referring to persistent storage. We will, which is kind of surprising at first, and we'll talk about why. But we will actually store a plain text password and handle plain text passwords in RAM. Our program will have that password in memory at some point, but it will never persist. It will never be on disk. It will never be in our database as plain text. So now not even the admins should be able to read this, because we're going to use this big buzzword, hashing. We're going to hash these passwords and only store the hash of a password. How do we know that a website doesn't save our passwords as plain text? Well, here's the rub. You don't. You just don't. You don't know. Is that a non-satisfying answer? Because, yeah, you just don't. And if somebody wants to shout out any site that uses passwords, I'll do a quick experiment. I do this when we talk about this in any lectures. If anybody wants to shout out any site ever that uses a password to authenticate somebody, I'll show you that password is being sent to the server, and that server is handling that password in plain text. Any site. I'm not just to prove that I'm not setting this up beforehand. I'm not like, I know this one site over here does something bad. Any site you want to mention, I'll go to that site. We'll open up the browser, Code Wars. Let's do it. And I'll show you that they're handling plain text. I haven't seen one yet, so maybe let me do a private browser just to be extra sure. I'm in the wrong window. I made it pretty far this time. Codewars.com. I'm going to get one of these days, the day might be today, where one of you knows that a certain place doesn't use plain text. Yeah, whatever. I don't actually have an account. I don't know why I typed an almost real email address. I think I fat fingered that a bit. So let's go to sign in. If I go to my password, that password was sent in the body of this request as plain text. It's a plain text password going over the internet. And this is how every site, at least that I've seen, I haven't seen one that doesn't do this. And we can talk about it maybe during Q&A. I don't know if we'll have lecture time this week to do this. But there is no point in not sending the password plain text. There's nothing you can gain by not sending this password in plain text. These passwords are always sent plain text over the internet. Always, always, always. Everything that I've seen. You can do something else. You can send a hash of the password, but you don't gain any security by sending a hash of that password. Hashing is only for our storage in the database on the server. That's the only time where hashing is actually effective, where it actually adds security and adds privacy. So these passwords are always flying around in plain text constantly. That's why HTTPS is so important, because that password is encrypted when it's going through the air. So people still can't read it, but when the server receives that password, they're going to decrypt it and handle our actual plain text password. That password will be handled in plain text. Then it'll be immediately hashed. It'll be salted and hashed, and then compared with our salted hash in the database. But they do handle in RAM a plain text version of your password. So if somebody is able to get some spyware, some malware installed on the server, when you log in, they can grab your plain text password right there. So something to be aware of. And we can talk at length about why that's the case, why we do that. There's nothing that we can do to add security at that point. So we're going to use a hash function. Hash functions have a lot of features. We want to take in some value and output some other value. Typically, we want this to be a fixed length output, and usually we want these to be somewhat random looking. These are used for to build hash tables, of course. For hash tables, a uniform distribution is one of the biggest things that we're looking for there. Any two values should just have 1 over n probability of colliding. We want to avoid those hash collisions, so uniform distribution is important for us. Hash functions don't add any security. Sometimes I deliver that going for shock value and stuff. Not going to bother with that here, but cryptographic hash functions do. So cryptographic hash functions are a subset of hash functions that do give us some security properties. These are hash functions meant to be secure, meant to add actual security for our purposes. Just a regular hash function, you can have a regular hash function that doesn't add any security. So just because you're using some hash function, for example, if you're in Java, you have some object, and every object has a hash function associated with it. If you do .hash and then store that in your database, you have zero security. That's not a secure hash function, unless you override that hash function, of course, with a cryptographic hash function. But the cryptographic hash function is what we want. Just because you hash something doesn't mean you have any security. If you hash something with a cryptographic hash function, you might have security. Not always, though, which we'll talk about. So with a cryptographic hash function, the intent is to be a one-way function. We have some plain text value. We hash it. We get some random-ish looking garbage. And it should be next to impossible to go from this hash back in the other direction to this original plain text, this original password. We want that to be next to impossible to be able to do. You can compute these. I'll use SHA-256 for all my examples, and I recommend that for the homework if you, unless you are keen on hash functions and you want to use some other one. SHA-256 is a good one. We saw very briefly earlier in the semester SHA-1. SHA-1 is not secure anymore. There are known attacks for that. It's not really used for security. SHA-256 is still pretty solid. This is still used out there in the wild quite a bit. And SHA-3 is actually out. If you want to use in your homework, if you want to use the latest cutting edge, SHA-3 exists. SHA-3 is out there. So with this, and here's an online tool you can use to compute SHA-256 hashes. If we do password, the literal string password, we'll actually see. I have PDF slides now. So 2D8, we'll just kind of guess based on that. 2D8. This is the actual SHA-256 hash of the actual string password. So SHA-256 is a standard algorithm. If you use that website that I just showed, if you use Java, if you use Python, no matter what, you're going to get the same value. And we saw this with WebSockets. No matter what language you're using, as long as you use SHA-1, SHA-1 has a very clearly defined definition that no matter what you're using, it's going to be the same. So SHA-256 hash function that we'll talk about. I won't talk about the details of it, but this picture should give you a decent idea of what's going on. It's a whole bunch of bit level stuff. So, and it's a lot of like scrambling around the bits of the input. This is very fast to compute and very difficult to reverse. Would take a very, very long time to reverse. Is there security to hashing twice? No, not really. Can we have homework 8 released early? Come on, man. Homework 8 is released. I talked about it at the beginning of the lecture. Yeah, wake up on time, man. So there's not really security to hashing twice. The reason for that is SHA-256 itself has several rounds of hashing. The output goes back into the input multiple times. If there was added security to doing this twice as many times, that would just be part of the algorithm itself. So when they designed the algorithm, they effectively hashed as many times as they thought would add more security, and then they stopped once they said, you know what, there's no point in doing this anymore. There's a little obscurity that you can get with hashing twice, just because attackers wouldn't be expecting that. But once they know that you're hashing twice, if they have access to your hashes, they probably have access to your code, and they'll just see that you're hashing twice. Once they see that, there's no added security. Yeah, there's always Q&A session. Every day I'll do Q&A till at least 11:30. So let me get through 2 minutes, 1 minute. What's the one thing I would want to get into this lecture? Let's do this one. I'll just put an exclamation point on that. No. Wait. Nope, not going to do that. Good thing I just wait till Wednesday for that one then. I think I know why. I think I'm... I think I know what happened there. But anyway, so let me do just one more slide. I'll set this up and then I'll knock it down on Wednesday. So it's next to impossible. There are some theoretical attacks on SHA-256 specifically, but it's next to impossible to take a hash and go backwards back to the plain text. However, by design, it's always efficient to go from plain text to the hash. So just because you're hashing, if you're hashing, it's next to impossible to go backwards, but it's super easy to go forward. So this enables what we call a brute force attack, is where you just keep guessing, hashing, and if the hash matches, you just crack that hash. Very easy to attack. So for example, if you're hashing, if you want to say either yes or no, if you have some binary response where there's only two choices, and you hash it thinking, well, nobody can read this because it's hashed, and then you send that hash to somebody and thinking that you had some makeshift encryption going on, well, somebody who recovers that hash just tries to hash yes, tries to hash no, and sees which one matches the hash that you sent. Absolutely no security here. So just because you're hashing does not mean that you have security or privacy. You don't have anything protected just because you're hashing. You have to have enough entropy as well. You have to have enough entropy, which is to say there has to be enough guesses required to be able to crack your hash, to be able to brute force your hash, to be able to actually say that you have any security. So if you have, for example, 2 lowercase letters in the English alphabet, you have a total of 676 guesses, which will take less than a millisecond on any modern processor to be able to crack your hash. So we need a lot of entropy, a lot of randomness in the guesses, so they can't brute force these hashes, which is why even with hashing, we still have all these password criteria: uppercase, lowercase, number, special character, at least 8 characters. we still have all these criteria, so we can have strong passwords with strong hashes that can't be cracked in a millisecond. That would take a prohibitively long time to crack. That's what we're after. That's what we want. So as we increase the what we call the alphabet size by saying uppercase, lowercase, etc., we can increase the alphabet size, and then by increasing the length, we'll increase this exponent. And if we can say, well, let me pull up my calculator actually. So if we say we have the 26 characters, uppercase and lowercase, the 10 numerics, and I think there are like 20, 30, we'll say there are 30 special characters, let's just say. And then, where's my exponentiation? I got no menu. I can't do exponentiation on Windows calculator, apparently. That can't be right. There we go. So we were at 92, and if you have a length 8 password requirement, and you have complete randomness, a purely randomly generated password in this space, then you have this number of possible passwords, and that's how many guesses somebody's going to have to make to be able to crack your password, to guarantee that they'll crack your password. They might get lucky and take fewer guesses than this. But this is, 1,000, million, billion, trillion, quadrillion, 5.1 quadrillion guesses. Still not a great number. If they have some high-end GPUs that they're using to crack this hash, this is still feasible. They can still do this. In, maybe it takes them a day, but this can still be cracked. But they're gonna have to want to crack your password. Unless they really want to target you, they're going to get the guy with password with an @ symbol for the A and a 1 for 5 for one of the S's. They're going to get that person first instead of cracking you if you have a truly random password that meets the criteria. All right, so let's... and I can talk about that in depth a bit more Wednesday if we have time. I might just plow through and get through the more practical, what does this mean for your app.